Hi grade 10s and welcome to this video. In this video we will be working on Eastern Cape's grade 10 mathematics test, and this is specifically from August 2025. The marks allocated to this test is 50 marks and you have 1 hour. Moving on to the instructions, just remember that we're going to round off to 2 decimal places unless stated otherwise, and the diagrams are not necessarily drawn to scale. Okay, with that being said, let's get into this video. Question 1 says, given the equation h of x is equal to negative 2 over x plus 2. Okay, so grade 10s, do you see that we have an x in the denominator? This means that the graph that it's going to create is a hyperbolic function, okay? So they want us to determine in 1.1 the x-intercept of h. To find the x-intercept, remember, this is where the graph intersects the x-axis. When it intersects the x-axis, its y value is equal to 0. So it is 2 as an x value and 0 as a y value because it's 2 to the right and nothing up or nothing down. So we're simply going to make y equal to 0 in our equation. So we have h of x, and h of x stands for y. Okay, if you rewrote this as y equals negative 2 over x plus 2, it's the exact same thing as h of x. Okay, it means the same thing. So in place of h of x, we substitute 0, and now we just have to solve for x here. You can choose to take the 2 over or the negative 2 over x over. If you take the negative 2 over x over, the 2 becomes positive, and then you have 2 over x. Okay, this doesn't become negative. This is a fraction that is negative, okay, as a whole. And when it comes over, it just becomes positive. It's equal to 2. And then we need to solve for x. So to solve for x, you can just cross multiply. So you can put this over 1 and then multiply denominator times numerator here. That gives us 2x. And then 2 times 1, that gives us 2. And now finally divide both hand sides by 2 to solve for x. And so x is equal to 1. Okay, they asked for the x-intercept of h. They didn't really say as a coordinate, so you can leave it like this. But as a coordinate, it would be 1 and the y value is 0, remember. Okay, so like that or as a coordinate is fine. Moving on to the next question. Question 1.2 says, calculate the y-intercept of h. So we know that the x-intercept, this is where y equals 0. So when we have a y-intercept, this is where x is equal to 0. So we'll take h of x, and we can just start by saying h of 0 in place of x. So wherever you see x, substitute 0. So this is negative 2 over 0 plus 2, and you can already tell what's going on here. If you have negative 2 over 0, okay, anything over 0 is undefined. So this is undefined, there is no y-intercept. So you can just say y has no solution, or there's no y-intercept. Or really h of 0 has no solution, and that is fine. Okay, moving on to the next question. Question 1.3 says, write down the equation of the asymptotes of h. They say asymptotes, but in grade 10, you know that you guys deal with one asymptote for the hyperbola. Okay, so here's what your hyperbola looks like. Remember that it is in the form of y equals a over x and then plus q. And this is your asymptote. It's a horizontal asymptote. So it's a horizontal line that the graph will never touch. So because it's a horizontal line, you're just going to call it y is equal to. Because it's a horizontal line, it passes one particular y value on the y-axis. So we say y equals whatever y value it passes. So we can see that this q value here is 2. So our horizontal asymptote is simply y is equal to 2. Now, technically, you do have a vertical asymptote. You just don't really speak about it much, but it is there. See, the thing about the vertical asymptote is, in grade 10 for now, it's still just going to be x is equal to 0 all the time. Okay, vertical asymptote will just be x is equal to 0, and then you could just leave it like that. In grade 11, you will start seeing that they will start adding a shift there, and then you can actually see the vertical asymptote, okay, other than 0. So y equals 2 and x equals 0 for your vertical asymptote. That's why when we try to substitute 0 in place of x, it didn't work because there's an asymptote at x is equal to 0 since the graph doesn't have a y value here. Okay, so that is our answer. Moving on to the next question. Question 1.4 says, hence sketch the graph of h, clearly show all intercepts with the axes and then asymptotes. Okay, so to draw your graph, just simply draw a Cartesian plane. Doesn't have to be special, you don't have to overthink the numbers. We're just going to focus on certain things. So that's our x and our y axis. And then first draw down your asymptotes. You know that you have a horizontal asymptote of y equals 2. So just draw a horizontal line passing 2 on the y-axis. Okay, so there we go. Y is equal to 2. And then you also have a vertical asymptote of x is equal to 0. So that's a vertical line, but you see that it's just going to overlap the y-axis. So you don't really have to draw it down. Okay, you can just say we have an asymptote of x is equal to 0, and then that's fine. And now let's draw our graph. So we can put down our points. The only point we have currently is the x-intercept, okay, of 1 and 0. So on your Cartesian plane, just go 1 and 0, that's 1. And there we go, that is our x-intercept, 1 and 0. And now we need to know where our hyperbola is going to lie. So based on what we have here, do you see how the value of a, okay, is negative? If a is positive, your graph will lie in the first and the third quadrant. If a is less than 0, the graph will lie in the second and the fourth quadrant. So we know where our graph will be. So it's going to be in the second and the fourth quadrant. You can already see. So it's going to come from being really close to the y-axis, and then it's going to shoot up past that x-intercept and move closer and closer to this asymptote but never touch it. And then this wing over here is just going to copy what this one is doing. So it does this and then like that. Moves closer and closer to the y-axis. And this one comes from being really close to this asymptote. And this is the graph of h, and you can just label it h. And that is our answer. And that is it for question 1. Question 2 says the graph of f of x is equal to a to the power of x plus b. So we can see that this is an exponential function. It's an increasing exponential function. Okay, if you read it from the left to the right, it is moving up. And they say that this graph is drawn below. And then b is the y-intercept, as we can see, of f. Use the above graph to answer the following questions. And 2.1 says, write down the equation of the asymptote of f. Do you see how they already give you the asymptote? Okay, we have a horizontal asymptote, and the equation is y is equal to 2. So you're literally just copying off the graph. Y is equal to 2 is our answer. Moving on to the next question. Question 2.2 says, determine the values of a and b. Okay, and a and b are in the equation of f. So there are two things you need to find, meaning they need to give you two pieces of information. From the previous question, you see that you know what the asymptote of f is. It's y equals 2. Okay, that asymptote value, you need to remember where it goes in your exponential function. As written here, okay, we have y or f of x is equal to a to the power of x plus b. This b value, that is your horizontal asymptote. So that value we had was 2. So that is the value of b. b is simply equal to 2. And now we need to find a. So now that we know that our graph, okay, we can just update this equation. So the equation of our graph is a to the power of x plus 2. How do we find a? Well, you will be able to find a if you had a y value, because f of x is y, and you had an x value. So if you had a point on this graph, do we have a point? Yes, we do. We have 2 and 11. So we can substitute 2 and 11 in place of x and y. So this is the x value, that's the y value. Okay, so f of x, that is our y value, we'll say 11, is equal to, and we have a to the power of x, which is 2, and then plus 2. To solve for a, you can transpose the 2. So 11 minus 2 is 9, and then is equal to a squared. And then square root both hand sides. If you square root and you square root, I know that we have to consider the positive or negative solution, but this is an exponential function. Your base should not be negative. So our final answer here is a equals the square root of 9 is 3. Okay, so there we go. The value of b is 2 and a is 3. Moving on to the next question. Question 2.3 says, write down the range of f. Okay, grade 10s, remember what the range of a function is. The range of a function would be all the y values of this function, all the possible y values that this graph can have. So let's look at our function and then just see the y values that it has. So this is an exponential function and look at all the y values it has. Look at this point over here. Its y value is this positive value over here. This point over here, its y value is this. This point over here, its y value is that. This point, its y value is 11. And you see how we just have positive y values all through. So how we tell them all the y values that we have for this graph, you're going to have to look for places where the graph doesn't have any y values. And that would be where we don't have any graph. So down here, do you see below this asymptote of y equals 2, there is no more graph below here. So it means that the y values, because we know that the asymptote is the line that the graph will never touch, it just moves closer and closer to it, or, comes from being really close to it. This would mean that the y values of this graph, the range, would be all y values that are simply greater than 2. Because this is 2 over here. It's never going to touch 2. Okay, it never reaches a y value of 2, but it has y values that are all greater than 2. And so how we tell them that is our range is y is greater than 2. You can write it like that in set builder notation, or you can write it in interval notation, which would look like this. You're saying that y is greater than 2. Okay, so you're starting at 2 and you're heading towards positive infinity. So we would say y is an element of, and you're going to say 2 all the way to positive infinity. But you see that y is just greater than 2. It's not equal to 2. So for 2, you will use a round bracket. And then for infinity, you also use a round bracket because infinity is not a fixed number. Okay, so that is our answer. You can write it like this or like that. Moving on to the next question. Question 2.4 says, determine the coordinates of B. Okay, show all your workings. So B, as we can see, this is a point on the y-axis, meaning this is a y-intercept. And we know that at the y-intercept, this is where its x value, that point's x value, is equal to 0. So we're just going to take the equation of our function, which we actually have now. See, we know the value of a, so we'll just put it in here. And all we are doing is making x equal to 0. So we know that the value of a, that was 3. Okay, so in place of a, just put 3. And now to find the y-intercept, you're just going to make x equal to 0. So in place of x, you substitute 0. So it's equal to 3 to the power of 0 plus 2. And anything to the power of 0 is 1. So 1 plus 2 is 3. So we just got the y-intercept, but you need to write it as a coordinate. So as a coordinate, remember that the x value is 0, the y value is 3, and that is b. So that is the coordinate of b. Moving on to the next question. Question 2.5 says, determine the equation of t if t of x is equal to 3 f of x minus 1. Okay, when two things are put together, for example, if I said a, b, what are these doing? Are they being added? Are they being multiplied? Are they being subtracted or divided? They are being multiplied. Okay, a times b gives you ab. So with 3 and f of x, all it just means is they said this new equation is formed by saying 3 multiplied by f of x. So we'll take whatever f of x stands for and we're going to multiply it by 3. And then all of that will subtract 1 from it. Okay, so f of x, we know this now is 3 to the power of x plus 2. So in place of f of x, we'll just say here 3 and it's multiplied by, 3 to the power of x plus 2. And then we still have the minus 1. You see, we have just substituted f of x in place of f of x, the equation of it. Okay, the only reason we're using brackets is because this has two terms. Here's the plus sign. Terms are separated by plus or minus signs. That's one term, that's two terms. So you need a bracket to multiply one term to two terms. Okay, let's go ahead and distribute. So these are just sitting together. So we're saying the 3 multiplied by 3 to the power of x. This is 3 times 3 to the power of x. Notice how the bases are exactly the same. So if the bases are the same and you're multiplying, you're going to add your exponents. So leave the base the same and then add the exponents. We have an x in the exponent there. And what's the exponent we have here? It's a 1. Okay, so it's plus 1. And then so we've multiplied those. Now we multiply these two. So 3 times 2 is positive 6. And then we have minus 1. So this is still t of x. So therefore, t of x is finally equal to, we still have 3 raised to the power of x plus 1. And 6 minus 1 is equal to 5. And that is our answer. And that is it for question 2. Question 3 says, in the diagram below, the graph of f of x is equal to negative 3 sine x is drawn for the interval where x is greater than or equal to 0 degrees, but less than or equal to 360 degrees. Okay, so it goes from 0 degrees all the way to 360 degrees. And 3.1 says, write down the amplitude of f. So the amplitude of a graph is the height of the graph, but from the middle. So from the midline. So we can see that the highest it reaches is 3, the lowest it reaches is negative 3. So the middle would be at 0. If you check the height from that midline to the highest point, that is exactly 3 units. You can also see this from the equation of your function. Because it says negative 3 sine x, we can see that the amplitude is always going to be the absolute value of this. So if it's negative 3, the length of that is just 3. Okay, the absolute value is 3. So that is the amplitude. The amplitude is 3. Okay, we can just say 3. Okay, moving on to the next question. Question 3.2 says, write down the minimum value of f of x plus 5. So the lowest value that this graph f of x plus 5 would reach. Okay, you can think about what the minimum value of f of x is currently. So you see your graph of f, right? It reaches a lowest of negative 3. So currently f of x minimum is negative 3. But the graph they want you to find the minimum value of is f of x plus 5. So when you add to a function, okay, not to the x, okay, but f of x. Remember how f of x stands for y? If you're adding to a y value, you are shifting this graph up. Okay, if you had a point and then it was a, it was 1 and 2, and I added to the y value and I changed this. I said, let me add 2 to this y value. It will become 1 and 4. You see how from here to here, that would shift that point up by 2 units. So if the minimum used to be negative 3, but we know that this graph that they're referring to, f of x plus 5, that was shifted 5 units up, then where's that new minimum going to be? The old minimum was by negative 3, just move 5 units up from negative 3. So say negative 3 plus 5. Okay, so negative 3 plus 5, shift 5 units up, that gives us positive 2. So the minimum value of this expression is 2. You can actually take it up and just shift it. So that's 1, 2, 3, 4, 5. Do you see how the minimum is 2? And that is our answer. Okay, moving on to the next question. Question 3.3 says, on the same set of axes, draw the graph of p, which is p of x is equal to tan x for the interval, the same interval really. Okay, let's just go ahead and draw that graph here. So it's a tan graph. The tan graph, remember that from grade 10, this is really where you need to learn your graphs. Your trig graphs should be learned properly in grade 10. So the graph of y equals tan x, in this case p of x, okay, which is just y really. So tan x, this graph completes a cycle in 180 degrees. Now what we mean by a cycle is how long it takes to repeat itself. So the graph looks like this. It starts at 0 and then it goes all the way up, okay, moving closer and closer to its asymptote, which is at 90 degrees. And then it comes from being really close to the asymptote and then hits a y value of 0 again. Okay, and this is at 180 degrees. And then this graph really just continues. You see this pattern that we have where the graph goes up and then has an asymptote, comes from being really close to the asymptote. It just continues every 180 degrees. So this graph would exist from 180 degrees all the way to 360 degrees. And then even before this, you'd have the same thing going on. You have the graph going up, reaches an asymptote, and then comes from being really close to the asymptote and then hits 0 on the y-axis again. Okay, or y value of 0. And that would be from negative 180 degrees all the way to 0 degrees. So that's what we mean by a tan graph repeats itself every 180 degrees. Now, because of that, there are just specific values you need to remember that would be important to draw your graph. So with the tan graph, because it repeats itself every 180 degrees, it's better to draw it in intervals of 45 degrees. So at 0 degrees and then 45 degrees, then 90 degrees and then 135 degrees and then 180 degrees. Okay, so you just need to find the y values at these points and you can use your calculator to do this. Okay, so on our graph at 0 degrees, what is the value of tan x? So you just say tan, and in place of x, okay, your angle, you substitute 0 degrees. On your calculator, you'll see that that gives you 0. Okay, so tan 0 is just 0. And then we're moving in 45 degrees, remember? So try 45 degrees. Tan 45 degrees on your calculator will be equal to 1. Okay, so 1, you have that over here. And then tan 90 degrees, you will notice that it's going to give you an error because you have an asymptote. So here we will draw our asymptote. It's going to be a dotted line that the tan graph will never touch. And then after this, 45 degrees later, we have 135 degrees. So the y value at 135 degrees, you can go ahead and try. Tan 135 degrees, you're going to get negative 1. Okay, so this is 45 degrees and 135 degrees and negative 1. And then tan 180 degrees, you're going to get 0. Okay, so it should just follow the shape of your tan graph. You know the way it goes up and then like that. So there we go. We're going to draw it like this. Moves closer and closer to the asymptote, never touching it. And then comes from being really close to the asymptote, passes negative 1, and then there we go. And then this graph will just repeat itself every 180 degrees. Because this interval goes all the way to 360 degrees, we will have another cycle of the tan graph over there. So again, we have 180 degrees and 0. 45 degrees later, we are at 225 degrees. This is where we'll have a y value of 1 again. Okay, all of these values, they're just repeating themselves. So here where we had a y value of 1 at 45 degrees, this same y value of 1 appears 180 degrees later. If you said 45 degrees and then you went 180 degrees to the right, so plus 180 degrees, you would get 225. Okay, you can go ahead and check. Tan 225 degrees. So all you have to remember is with the tan graph, just move in intervals of 45 degrees and you'd be able to catch most of the values that you're looking for. Okay, so then at 270 degrees, if you try tan 270 degrees, you'll see that you have an asymptote again. Okay, because this asymptote repeats itself 180 degrees later. And then where we have 270 degrees, we're just going to go 45 degrees after this is at 315 degrees. And at 315 degrees, this is where we're going to have a y value again of negative 1. Okay, this, if you went from here and you went 180 degrees ahead, you get to 315 degrees. So there we have a y value of negative 1. And then we're back at 360 degrees and 0. That is the repetition of this 180 degrees and 0. Okay, so there we have a y value of 0 there. And then we just have the same pattern again. It goes like that, goes closer and closer to the asymptote, never touching it, comes from being really close to the asymptote and reaching there. And there we go. That is our graph. So you can just show that the asymptotes are at x equals 90 degrees and at x equals 270 degrees. Remember, it is x is equal to because this is a vertical line. It is a line that passes one particular x value on the x-axis. Okay, and that is what our tan graph looks like, and you can just go ahead and call it. They said p of x, so this is the graph of p. Moving on to the next question. Question 3.4 says, use the graph to determine the following. So 3.4.1, the value of f of 90 degrees minus p of 180 degrees. Okay, so f of 90 degrees just means that we are finding the y value of f at x equals 90 degrees. So let's look at the graph of f. So the graph of f is this sine graph that we have. Okay, so we can just highlight it in red. And you see that for the sine graph, where we have the x value of 90 degrees, what is its y value? Its y value is negative 3. Okay, so we know from the graph that f of 90 degrees is negative 3, and they were saying minus p of 180 degrees. So on the graph of p, the tan graph, what is the y value at x equals 180 degrees? And we know that y value, okay, of the blue graph, it has a y value of 0. Always just go to the y-axis to see its y value. So that is minus p of 180 degrees, which has a y value of 0. So this is simply equal to negative 3, and that is our answer. Moving on to the next question. Question 3.4.2 says, determine the equations of the asymptotes of p, okay, within the interval that they asked. So you see how we figured out where the asymptotes were, and I even wrote the equations as well, which you should always write down if you're drawing your graph. So this is our asymptote at x equals 90 degrees and at x equals to 70 degrees. So those are our asymptotes. X is equal to 90 degrees. That's the first equation of the asymptote we have there. And the second asymptote is at x equals to 70 degrees. Okay, where, x goes from 0 degrees all the way to 360 degrees. Moving on to the next question. Question 3.4.2 says, for which values of x is p of x less than or equal to 0? Okay, remember how p of x and f of x and g of x, all of these just stand for y, okay? So they're just saying, tell us where the y values of p are negative, okay? Where are they less than or equal to 0, negative or equal to 0? Okay, so I'll just do this using the graph of p, which is the blue graph. So when the graph has a positive y value, okay, where it's greater than 0, so if p of x is greater than 0, do you see that on the y-axis, since this stands for y, on the y-axis where we have positive y values, that would be all over here. See, positive 1, positive 2. That's where we have positive y values. So that means if you wanted to find positive y values on your graph, you would only search for places that, or parts of the graph that lie above the x-axis, because that's where we get positive y values. But they specifically asked us for where p of x is less than or equal to 0. So you're going to look for parts of the graph that lie below the x-axis. Okay, highlight all the parts of the graph of tan x where it is below the x-axis. So that is all through here. Look at that, below the x-axis. I can't take anything here, that's above the x-axis. And all through here. And now you just have to answer them in terms of x. So tell them the x values for which these pieces of the graph exist. Okay, remember it is less than or equal to 0, so we will also include places where the graph of p has a y value of 0. Okay, if you line these up to the x-axis so we can better understand what exactly these x values are, do you see that these are values that are, you can see it's comparing to 90 and 180. It's values that are greater than 90 degrees, but less than or equal to 180 degrees. Do you see that at 180 degrees, we have an x-intercept? Okay, at this point, this is 180 degrees and 0. Its y value is 0. That's why it's on the x-axis. So we can't really say the same for 90 degrees because there's an asymptote here. The graph won't even, it doesn't have a y value here. It's undefined. So we have x is, these are values that are greater than 90 degrees, but less than or equal to 180 degrees. So x is greater than 90 degrees or less than or equal to 180 degrees. That's our first solution. We can put that down. And we see that we do have another piece, another segment of the graph here that lies below the x-axis. So if you line this up to the x-axis to better understand these values, this is where, it's values that are greater than 270 degrees, but less than or equal to 360 degrees. As you can see, at 360 degrees, you have an x-intercept. And they did tell you that x is greater than or equal to 0 degrees, but less than or equal to 360 degrees. So 360 degrees is an actual x value that is included in this graph. Okay, so we know that. So this is where x is greater than 270 degrees, not equal to 270 degrees. There's an asymptote here for the graph of P, our tan graph, and then less than or equal to 360 degrees. And that would be our answer. And that is what our answers look like. Moving on to the next question. Question 3.5 says the graph of f is reflected about the x-axis and then moved 2 units upwards to form the graph of k. Determine the equation of k. Okay, so this new graph of k of x, okay, its equation, we will find it by taking the graph of f, and then we're going to reflect it about the x-axis and then move it 2 units up. So what happens when a graph is reflected about the x-axis? Let's understand this using a point. If we had a point over here, and I'm just going to call this 1 and 2, and we had to reflect this about the x-axis. So treat the x-axis as if it's a mirror and we're reflecting this. You see that if you're reflecting it across the x-axis, since from the x-axis to this point, we would have moved exactly 2 units up, then from the x-axis to the reflection, you would move exactly 2 units down. That would make this point 1 and -2. You see that 1 does not change. That stays exactly the same. We're simply just reflecting it, okay, across that x-axis. So what changed specifically? It's the y value. And what exactly happened to the y value? The original y value was simply multiplied by -1. And that's what happens when we reflect a point or a graph across the x-axis. The y value of that graph, all the y values, they just get multiplied by -1. So that takes care of the reflected about the x-axis part. We know what happens there. Okay, that graph of f, its y values, f of x, would just be multiplied by -1. But then when a graph moves 2 units upwards, what do? We saw this from, one of the first questions. If you're moving a point up, it's only going to affect which coordinate, the x or the y? It would affect the y because you're moving it up. So if you're moving it up, you add. If you're moving it down, you subtract. Very simple. Okay, so you're going to still take that y value and then add 2 to it. Okay, so what happens here is we have f of x, and what we're going to do with f of x is we're multiplying it by -1. F of x times -1, you can just call that negative f of x. And then whatever that gives us, that y value, we're going to add 2 to it. So this is how to mathematically write out what is going on. And now we're going to apply it into our equation. So the equation of k of x is equal to, we'll say negative, and then what is f of x? Remember that f is the sine graph, okay, -3 sine x. So it's negative times -3 sine x, okay? And then all of this is now going to be the new y value you have. You're going to add a 2 to all of that, okay? Because it must first be reflected and then shifted 2 units up. So k of x is finally equal to +3 sine x and then plus 2. And that is the equation of k. Moving on to the next question. Question 3.5.2 says, determine the range of k for the interval, okay, for that same interval. So this is this new graph of k. We're not going to draw it down. We don't need to. We just need to remember certain things about the graph, which was actually spoken about, in the first part of this question. Like, for example, the amplitude, the minimum value, things like that. So if you have this graph, 3 sine x plus 2. Let's talk about the 3 sine x and think about what this graph would look like. If the graph -3 sine x looked like this, where it reached a lowest of -3 and a highest of 3, what is the graph of 3 sine x going to look like? It's going to be a graph that will, so it's a sine graph, which looks like this normally. And all you just have to remember is that because this is 3, it means its maximum would be 3 and its minimum would be -3. So it reaches a highest of 3 and a lowest of -3. But then what happens is we have a plus 2. So then what happens? If you say plus 2, you're shifting this graph 2 units up. So its minimum used to be negative 3. What is its new minimum going to be? So negative 3, negative 2, negative 1, 2 units up. Okay, so it now has a minimum of negative 1, and its maximum is what? Well, its maximum used to be 3, but this graph was shifted 2 units up. So 3, 4, and then 5. So its maximum will now be at 5. So the question is, we need to tell them the range of this graph, the range of k. You can see that the range, remember, we spoke about the range being all the possible y values in this exam paper. Okay, this was in the function section when we were referring to the exponential function. Okay, so thinking about the range, all the y values that this graph has. Here's the y-axis. Look at all the y values it has. It has values that are from negative 1 all the way to 5, and then nothing beyond this, okay, and nothing below this. Meaning we can just tell them that our range is simply y values that are greater than or equal to negative 1, okay, because it has a minimum value of negative 1, but less than or equal to positive 5. And that is our range, and that is it for that question. You can write it like that. You can also write it in interval notation as y is an element of, and we're going from negative 1 all the way to positive 5. And because it is greater than or equal to, you use a square bracket to show that negative 1 is an included y value, and then a square bracket as well to show 5 is an included y value. So you can write it like this or like this. It's perfectly fine. And that is our answer, and that is it for question 3. Question 4 says 4.1, given the equation of r of x is equal to 2 cos x minus 1, sketch the graph of r on the grid provided for where x is an element of 0 degrees all the way to 360 degrees. Okay, so let me just go ahead and get that grid paper. Okay, so with the cos graph, you just need to remember which angles you should be focused on. So this is the graph 2 cos x minus 1. Do you notice how this is just still cos x? The coefficient of x is 1. So the period of this graph has not been changed. It's still functioning as that original cos graph. The period still runs the same. So we don't have to change any of these. Okay, we can just go ahead and find the values of 2 cos x minus 1 at 0 degrees, 90 degrees, 180, 270, and 360 degrees. Okay, so let's go. You can, on your calculator, substitute. So 2 cos of 0 degrees and then minus 1. We know that cos 0 is 1, but 2 cos 0 would be 2, and then minus 1 would be 1. You can also use your calculator as well. Okay, so that just gives us 1. And then next we need to try 90 degrees. Cos 90 degrees is 0, but 2 cos 90 degrees is just going to be still 0 because it's just times 2. And then minus 1 is negative 1. So that's minus 1. Okay, and then 180 degrees. I know that cos 180 degrees is normally negative 1. And then 2 cos 180 degrees would be negative 2. And then minus 1 is negative 3. And then 270 degrees, that's going to be cos 270 degrees is 0, and then 2 cos, it's just going to be 0, and then minus 1 is negative 1. And lastly, 360 degrees. So I know that cos 360 degrees is 1, and then we have 2 cos, so that's going to be 2, and then minus 1 is just 1. Okay, so you can use your calculator to verify. And so your cos graph, remember, it's curved. So this is the turning point. It's just going to go like that, and then like that, curve, and then like that, really. I'll just try to draw it better. Okay, so there we go. And that is the graph of R. And we can just go ahead and say that is R. Moving on to the next question. Question 4.1.2 says, write down the period of R. So the period of a graph is how long it takes to complete a cycle. So the cos graph, well, we can see what a cycle looks like. Goes up like that, down, and then back up again. So with this cos graph, you can see that the coefficient of x, okay, that's what's going to tell you whether the period has been changed or not. The coefficient of x here is just 1. So the period has not been changed. It still completes a single cycle in 360 degrees like the original cos graph. So the period is 360 degrees. That's how long it takes to complete one cycle. Okay, so one cycle just looks like that. Then 360 degrees later, it will have the same pattern again, and 360 degrees before this, the same pattern. Okay, and that is our answer. Moving on to the next question. Question 4.1.3 says, determine the maximum value of r. So we can determine this maximum value because we've already drawn this graph. So what is the highest value, the highest y value that this graph reaches? So its maximum, you see that the highest it reaches is 1. Also reaches 1 over there. So the maximum value of r is simply 1. And that's our answer. Moving on to the next question. Question 4.1.4 says, determine the range of r. So from question 3, you see that the range is all the possible y values of this graph. We can see that the y values that this graph has starts from this lowest value of -3 all the way to the highest value of 1. So we can just tell them that the range of the graph is where y is greater than or equal to -3 but less than 1. Okay, all values greater than or equal to -3 but nothing more than 1. Okay, and you can also of course write this in interval notation, which looks like this. You say y is an element of, okay, I was supposed to say less than or equal to 1. So y is an element of, and we start at -3 and then all the way to 1. And you see that it's greater than or equal to -3. So use a square bracket here and also a square bracket here because you can see that 1 is included. Okay, this is an actual y value on this graph. And that is our answer. Moving on to the next question. Question 4.2 says, the diagram below represents the graph of f of x, which is equal to a cos x and then plus q. Write down the values of a and q. Okay, so to find the value of a, you need to look at this cos graph and just look at whether it looks like a normal cos graph. Okay, we can kind of see what a cos graph looks like normally when that coefficient of cos x is positive. It goes like this, up from 1 and then it reaches, supposed to reach -1, but of course this is a little different because you have 2 here. So you can think about what the normal cos graph looks like. The original cos graph, okay, the mother graph, cos x, y equals cos x, it will reach a highest of 1 and a lowest of -1. And it really just looks like this. Okay. And of course, it completes the cycle in 360 degrees. This pattern is completed in 360 degrees. We can see that it is completing a cycle in 360 degrees. It's just that the cycle looks a little different. Okay. With this one, it looks like the number in front of cos x, okay, the number here is clearly negative, and that's why it looks like this. So you would notice that it's kind of upside down, really. So if you had to flip this, I can only do that if I turn this into an image. Let me just try to do that. Okay, so we have this, and if you had to flip it around, you see what we get. Okay, same pattern. Goes like that from down and then up. So clearly they made this value in front of cos x to be a negative value. Now we need to really just see what exactly it is. Is it -1? Is it -2? What exactly is that value? You can find out what it is by looking at the amplitude. So the amplitude of a graph would be the height of the graph from the midline, from the middle. To find the exact middle of the graph, take the highest y value and then plus the lowest y value, which we can see is 1, and then divide it by 2. That would be the middle, okay? So if you said 1 plus 3, that's 4, divided by 2 is 2. So the midline is here. And so the amplitude of the graph, from the middle, the height of this graph is clearly 1. So it means that the value that is here is actually -1. Okay, we see why it's negative because it's upside down. That's why it has this shape. And we see why it is 1 now. Okay, so we know the value of a. A is simply equal to -1. We'll say a equals -1. And then what is q? Well, think about what this graph should have looked like. You see that with the cos graph, we know the shape, okay, what it should look like. I just put this back. I put it like this. So if you look at this, you see that the midline used to be at 0, okay, the y value of 0. But now, where is it? It's now at 2. Okay, so it means that this is 0. It used to be here, and now it's at 2. So this means, how was it shifted? It was shifted up first, and by how many units? From 0 to 2, it means it was shifted up by 2 units. So that's the value of Q. It's positive 2. That's why it looks like that. So A equals -1, and Q is equal to positive 2. And that is our answer. Moving on to the next question. Question 4.2.2 says, using the graph, for which values of x is f a decreasing function? So where is f decreasing? We need to tell them the values of x for which f is decreasing. Okay, let's just look at what f is doing all through. You see, from here to here, what is the graph doing? When you read it from left to right, it is increasing. And then it reaches a turning point, and then it starts decreasing. So we can see that it's decreasing from here, okay, after that turning point, and then moves down like that. So it is decreasing for values that are, you can just line this down to the x-axis to understand what exactly these x values are. These are values that are greater than 180 degrees, but less than 360 degrees. So I'm not going to say greater or equal to 180 degrees because this is a turning point. This is the point where it stops increasing and it takes a turn, okay? And then it starts to decrease. So it was increasing, then it stands still, and then it starts decreasing, and then it stands still. Then if they had extended this interval, it would start increasing again. Okay, so we can see that these are values that are greater than 180 degrees, but less than 360 degrees. Okay, so I'm just going to go ahead and put that down. So x is greater than 180 degrees, but less than 360 degrees, and that is our answer. Moving on to the next question. Question 4.2.4 says, for which values of x is f of x greater than or equal to 2? Okay, so again, this is referring to our cos graph. Where is it greater than or equal to 2? So f of x. Remember how f of x stands for y? So where are the y values of this graph? Either greater than or equal to 2. So that's what we're looking for. So since 2 is over here, you can go ahead and draw a horizontal line because you'll see that all the parts of the graph that lie above this line, these will be parts of the graph that have points that are greater than 2. See that point over there, greater than 2. That point over there, it's greater than this y value of 2. But they want greater or equal to 2. So where is the y value of this graph equal to 2? You can see that is over here. You can just draw a horizontal line and you just check the places where the graph hits 2, okay? Hits this horizontal line. So this is where it has a y value of 2 at 90 degrees and here at 270 degrees. Okay, so since we know that, we can just line these other parts that we have highlighted down to the x-axis. And you can see that if you line it down to the x-axis, the parts that we have highlighted or selected, this is where x is greater than or equal to 90 degrees, but less than or equal to 270 degrees. Okay, all these values in between and including 90 degrees and 270 degrees. That would be where this graph has a y value greater than or equal to 2. So we'll tell them x is greater than or equal to 90 degrees, but less than or equal to 270 degrees. And that is our answer. Moving on to the next question. And the last question for this paper says, 4.2.4, write down the minimum value of f if f is shifted 3 units downwards. Very similar to the question in question 3. Okay, so think about the graph of f and where its minimum value currently is. So the graph of f has a minimum value at 1. That is the lowest that it reaches. You see that its highest is at 3. Its lowest is at 1. But what they're saying is this graph is then shifted 3 units down. So if it used to have a minimum at 1, then now the graph is shifted 3 units down. Its new minimum would be at 1 minus 3. So go 3 units down. Okay, 1, 2, 3. You end up at -2. So your only calculation here is just old minimum value minus 3, which is -2. So you can just say the minimum value is -2. And that is our answer. And that is it for question 4. Okay, so that is the last question for this paper. I hope you guys enjoyed it. If you have any questions, feel free to leave it in the comment section below, and I will see you guys in the future videos.